Hello everyone, welcome back to my YouTube channel. In this week video, I'm going to explain to you how you should answer quiz 5 questions. So altogether, we have 5 different questions and let's start with the first one. Question number 1. An electrolysis reaction between silver and chlorine gas was carried out at 30 degrees Celsius. The standard reduction potential for silver and chlorine gas is 0.8 volt and 1.36 volt respectively. Determine the Gibbs free energy change for the experiment. Right, so the first thing that we need to do is write the half reaction for anode, cathode, and also the overall reaction. So for anode, and for cathode. Given here is 0.8 and 1.36. So remember, the one that is more positive will do the reduction, right? So reduction occurs at cathode. So rate cat. So basically we have silver and chlorine, and apparently chlorine is more positive. Therefore, your chlorine should do reduction, which it will be at the cathode. So at the cathode will be chlorine plus 2 electron. It will produce chlorine ion. So because we have 2 here, so it becomes 2. Alright. So silver naturally will go for anode, whereby the anode will undergo oxidation. So silver minus electron, it will have silver plus. But you need to understand that we need to have a balanced equation between anode and cathode. So here we have 2, so you need to put 2 here, 2 here, and here as well. Therefore, we can have the overall reaction . So you have 2 silver plus chlorine gas. We should have 2 argentum ion plus 2 chlorine ion, right? Right, next up we are going to put their values. So around here, because for cathode, we can use it as is because the value of standard reduction, right? Because standard reduction. So for cathode itself, you can just put the value as is, 1.36 volt. But for anode, instead of having reduction, it goes oxidation. So this value of 0.8, you need to change it to negative 0.80 volt. So despite you having 2 over here, the value should be the same, only that you change from positive to negative. So when you do the summation of this, you will get 0.56 volt for the overall reaction. Alright, now the question asks you to determine the Gibbs free energy. So the formula delta G is equivalent to negative N Faraday constant times E naught. So what is N? So N is actually how many moles of electron that is taking part in this reaction. So basically we have 2 moles. So negative 2 mole. And then the Faraday constant is equivalent to 96.485 kilojoule per mole per volt. Lastly, your E naught will be 0.56 volt, which is this value. So from here, this is over volt, so you slash out this one, and this one is mole, this one is per mole. So you will end up having your final answer is equivalent to negative 1.0806 times 10 to the power of 2 kilojoule. So this is the Gibbs free energy change for this experiment and the answer for the first question. Alright, let's move on to question number 2. Determine the mass of copper in gram that shall be produced at the cathode by electrolysis of copper to positive solution using a current of 5.0 ampere for 15 minutes, given that the atomic mass of copper is equivalent to 63.546 gram per mole. Right, the first step that you need to do is use the formula Q is equivalent to IT. So I is the current, which is 5 ampere, and T is the time in second, because this one is given to you in minutes, so 15 minutes, 1 minute is 60 seconds, times 60, so you will get your Q is equivalent to 5 times 900, therefore you will get your Q is equivalent to 4,500 coulomb. Alright, so what we are going to do next is you need to convert this coulomb into Faraday. So basically, 1 Faraday is equivalent to 96,500 coulomb. So we are going to convert this. So 96,500 coulomb is equivalent to 1 Faraday. So you only have 4,500 coulomb. So what is the value? So 96,500 times 4,500. So you will get 4.6632 times 10 to the power of negative 2 Faraday. Alright, so now let us look at the balance equation here. So from here we can see that 2 Faraday, which is highly related to the amount of electrons that you're using, will produce 1 mole of copper, right? So this is how much Faraday that you have. Therefore, 4.6632 times 10 to the power of negative 2 Faraday is equivalent to 1 over 2 times this value. So you should get 2.3316 times 10 to the power of negative 2 mole of copper. So since you know the number of mole of copper, definitely you can find the mass. So the number of mole is equivalent to mass over RMM. So now you're going to find the mass. Is rather straightforward, is equivalent to the number of mole times your RMM. So the number of mole is what we have calculated just now, 2.3316 times 10 to the power of negative 2, and then it's given to you the atomic mass for copper is equivalent to 63.546 gram per mole. So this one is definitely mole. So if you slash this one, so you will get your final answer should be equivalent to 1.4816 gram. So this is the final answer for the second question. Alright, moving on to question number 3. Refer to the following reaction. Calculate the equilibrium constant Kc for the reaction at 25 degrees Celsius, given that the standard reduction potential for Fe3 plus and Cu2 plus is 0.77 volt and 0.34 volt respectively. So it's the same drill. We are going to look at this value. You have 0.3 volt and 0.77 volt. So whichever that is more positive will undergo reduction. So apparently this one is more positive. So this one belongs to Fe3+. Therefore, we can say that your Fe3+ will undergo reduction. So they will be put at cathode. Right, let's write the half reaction for anode and also cathode. So cathode, we know that it should be Fe3+ because it undergoes reduction. So Fe3+ will have this one electron and turn into Fe2+. So you're left with copper, which will undergo oxidation. So copper plus 2 electron. So you will need Cu2+, right? So here, because your copper needs 2 electron, you need 2 times everything with 2. So you have 2 Fe3+ plus 2 electron, and you will have 2 Fe2+. In saying that, we will have our overall reaction will be Cu plus 2 Fe3+ and Cu2+ plus 2 Fe2+. Alright, now it's the same drill for anode. So we have anode for copper, right? Here. So since it undergoes oxidation rather than reduction, negative 0.34 instead of 0.34. So for ferrum, you're going to use the same value despite you have times 2. Just use the same value. So you will get in overall, just a summation of this, you should get 0.43 volt. Okay, this is the first step to calculate your E-node cell. Alright, so now we are going to calculate what is the E-node cell. So E-node cell is equivalent to 0.059 divided by n log Kc. So what is n? Is the number of electrons. So apparently we have 2. So 0.059 divided by 2 log Kc. So your E-node cell is the one that you have calculated just now, which is this one. So 0.43 volt. So what we can do now is, you need to calculate this part first. It's equivalent to 2.95 times 10 to the power of negative 2 log Kc. So which is equivalent to 0.43 volt. So we will continue on with the normal calculus. So log Kc is equivalent to 0.43 divided by 2.95 times 10 to the power of negative 2. So you will get 1.4576 times 10 to the power of 1. Therefore, your Kc should be equivalent to 3.7670 times 10 to the power of 14. So this is the final answer for your third question. Alright, so up next is question number 4. Determine the oxidation number of manganese in KMnO4. So KMnO4, there's no charge. We can write as KMnO4 is equivalent to 0 because there's no charge. And you need to remember the rule. So for oxygen, it's always negative 2. And for potassium, should be the charge itself, so positive 1. So we are now left with the manganese. So we can say that positive 1. plus manganese, we don't know, we put X, plus oxygen is -2, but you need 2 times 4 because of this should be equivalent to 0. So 1 plus X plus -8 is equivalent to 0. Therefore, your X is equivalent to 8 minus 1. X is equivalent to 7. So the oxidation number for manganese in KMnO4 is actually 7. So this is the final answer for your fourth question. We are now at the last question for this week's video. Suppose a chemical reaction has a standard change in Gibbs free energy, delta G, of -200 kJ per mole. If the reaction was conducted at temperature of 298 Kelvin, calculate the equilibrium constant K for this reaction. Right, the first thing that we need to do is we need to look at the data that we have. So given here the Gibbs free energy is -200 kJ per mole. So what we want to do is we need to convert this kilojoule per mole into joule per mole. Therefore, we can write your Gibbs free energy is equivalent to -200 kilojoule per mole. This value you need to times 1000 because kilojoule you want to make it into joule, right? So it should be equivalent to -2.0 times 10 to the power of 5 joule per mole. Okay, this is the unit that we need to use in order for us to find the equilibrium constant. Right now, we can start to calculate the equilibrium constant, which is K. So now we need to just put in the values over here. So -2.0 times 10 to the power of 5 joule per mole. Right, so you divide it with your gas constant. So for here, gas constant will be 8.314 joule per mole per Kelvin. And your temperature is in Kelvin already, 298 Kelvin. So now we can say that here we can slash out the Kelvin. Now joule per mole, and then here. So eventually you will get your value of K is equivalent to 1.1417 times 10 to the power of 35. So this is the final answer for your fifth question. Alright everyone, this is the end of this week's video. Thank you very much for watching this video from the beginning till the end. So I hope this video will help you to understand more on how you should answer quiz 5 questions. So I'll see you again next week. Take care and be good. Goodbye.